All right, we are rolling into 9.3, which is all about rotations. So we're taking points and rotating them around a point, kind of like the hand of a clock is rotating around the clock, with the center of the clock being the point in which you're rotating around. One thing to note that is really important with our rotations, unless otherwise said, go counterclockwise. Always go counterclockwise unless you are told otherwise. No matter what. Always assume you're going counterclockwise unless it says clockwise. Always assume counterclockwise. So I'm going to start with a point, and that point's going to be my kind of kickoff point. And so I'm going to use the point 3, 4. So to 3 and then 4. 1, 2, 1, 2, 3, 4 right here. So I have this point 3, 4, and I want to rotate it 90 degrees around the origin. So our origin is our center point here, and so I want to rotate that 90 degrees around the origin. Well, how do we go about doing that? Well, what do we know about things that are 90 degrees? What do we, especially with graphing, when we're graphing, if things are at a 90-degree angle, we often call that perpendicular. And so if I wanted to do something that was perpendicular, I would need to know the slope of that point in which it is rotating around the origin. So if I connect a line to the origin from my point and I find the slope, see, I go up 1, 2, 3, 4, and over 3. So my slope is 4 over 3. I'm going to write that a little smaller and sideways. So I have a slope of 4 over 3. And if I were going to move perpendicular to that, I would need to find the opposite reciprocal. So if I'm going to rotate from my point and go to the opposite reciprocal, I need to change my slope. So if my slope is originally 4 over 3, my new slope would need to be negative 3 over 4. And so from that origin, I'm going to go 1, 2, 3, 1, 2, 3, 4, and rotate to my new point, negative 4, 3. So I took my original slope from my point 3, 4, and the origin. I found the opposite reciprocal, which is negative 3 over 4. And from the origin, I went up 3 and to the left 4 to find the point in which I would rotate. Now these two lines that meet at the origin are now perpendicular. So if you look, I took my 3 to 4 and rotated 90 degrees about the origin. 90, not 9. And if we look and compare what happens between, stop, notifications go away. If we stop and compare what's happening at our points. So look at your points, see what they kind of look like. You're going from 3, 4 to negative 4, 3. So we're keeping the same types of numbers. Nothing's changing with these numbers as far as we're not going to a 5 or an 8 or a 6, but the location and the signs are changing. So we started off at X, Y, and when we rotated 90 degrees, it turned into negative Y, X. So if we're just rotating about the origin, we have this shortcut where if we rotate 90 degrees, if you look at the bottom of your screen, it goes from XY to negative Y, X. Now we're going to do that again and keep rotating our circle. So if I rotate another 90 degrees, if I want to keep going, another 90 degrees. So from negative 4, 3, I'm going to do the opposite reciprocal slope again, which would be 4 over 3. And so from the origin. I'm going to find my point using my slope, but I'm going to go into the quadrant to the bottom left as opposed to going up. So that means I need to go down 4, 1, 2, 3, 4, and over 3, 1, 2, 3. So this new point is at -3, -4. Hi, Ashley, get off the table, please. And we have rotated an additional 90 degrees. But if you're rotating an additional 90 degrees from the very beginning, how much have you actually rotated? From that original point 3, 4, I've rotated 90, and then I kept going and rotated another 90, so I actually moved 180 degrees. And I'm going to compare these points again. When I move 180 degrees, what happens to your x and y? The signs change. So we started off with x and y, and then -x, -y. So we'll fill out our little table here at the bottom. -x, -y. Now what if I rotate again? What's going to happen? I don't know. So if I rotate an additional 90 degrees, I'm going to use the opposite reciprocal of that slope of my green line of my 180. So my new slope is going to say -3 over 4. And I'm going to go down 1, 2, 3, and over 1, 2, 3, 4. And I have a new line that is perpendicular. And it's at the point for -3. So if I look back at if I have traveled from the very beginning at 3, 4, I go 90. I go an additional 90 to hit 180. And then if I keep going to this point, I've actually traveled 270 degrees. 270 degrees. So that means my x, y, if we compare those to the original 3, 4, we now have y at the front and a -x at the back. Now what if I said to rotate another 90 degrees? Where do you think you would end up? I think you would end up right back where we started from. So if we take a look at what this does, whoa, don't do that. We have actually just created a circle. It's a fixed circle that we are rotating around the circle in. So we just keep moving along and along. If you look at our starting point, which was the 3, 4, and our 180 degrees, those have the same slope. They are on one line together, as well as the 90 degrees and the 270. They're on the same line together. It's real interesting, guys. So our 270-degree rotation is y, comma, -x. So you are going to have to memorize these steps. You're going to need to remember that your 90-degree rotation takes your x and y and turns it into -yx. You're going to need to memorize that 180 degrees just makes your x and y negative. And you're going to have to remember 270 degrees is y, comma, -x. And also, again, most importantly, remember that unless it's otherwise suggested, you are going counterclockwise. Counterclockwise. So let's look at 3 points and see if we can follow along. So if we have the point 6, -1, and we're rotating 90 degrees. So look at what it suggests for you to do in the box. It takes your x and y and changes positions. Your y comes up to the front and changes signs. And your x goes to the back. So you get 1, 6. Now if we're rotating the point 0, 2, 180 degrees, we just make them both change signs. Since 0 is neither positive nor negative, it doesn't change signs. It doesn't really move, but the y does. And then if we are rotating 260 degrees, the point 6, -1, you bring that y to the front and the x to the back and change the sign. So you have -1, -6.